As we see this signed area, the left-handmost triangle is underneath the x-axis, and the right-handmost triangle is above the x-axis. If I want to utilize geometry to find the signed area here, I need to count the area of this bigger leftmost triangle as a negative and the smaller rightmost triangle as a positive. Once again, these are just triangles. So I am going to utilize triangular areas. The left-handmost triangle, I'll call that the first triangle. The right-handmost triangle, I will call the second triangle. The first triangle, since it is underneath the x-axis, counts as a negative. I can still find the area though. Notice this is a right triangle, so the height is -3 and the base is 3. So the height and base are both 3 for the first triangle. That means the area is 1/2 times 3 times another copy of 3. When you calculate that, you get 4.5. The second triangle has a base of 1 and a height of 1. So the second triangle has area 1/2, 1 multiplied times 1. So you get 1/2 or 0.5, doesn't matter how we write that. Now remember, the signed area is these two triangles combined. The one below the x-axis will count as a negative, and the one above the x-axis will count as a positive. So in this case, if I want to find the signed area, I would take a -4.5 because that's the triangle below the x-axis, plus a positive 0.5. That's going to yield out a -4. So that's what the signed area does and looks like. This is obviously not an extensive list of different areas, signed areas you could figure out. You can figure out a lot of different things using just geometry alone. And we're going to cover what happens when you can't use geometry alone in some later sections.